So, you wanna know how to create a powerful AI that can think for itself, make decisions, and perform actions? Well, you've just stepped into the right tutorial. In the background, you can see an example of an AI system we are currently working on for a game called Whispers from the Past. The AI will patrol the rooms, looking for the player, and if it encounters a closed door, it will kick it, or break it if it's locked. When the AI is able to see the player, it will rush at him, and when close enough, it will attack. Seems simple, right? Well, here is the diagram for it. But don't worry, we're gonna create a way simpler example. I have prepared here a simple scene with a platform, a few obstacles and two capsules. The blue one is the player and the red one is the enemy. Both of them have a navmesh agent and the player has a simple script, click to move. You can click wherever on the platform and it will move to that specific point. Now for our system we will use something called a state machine, which is like a set of instructions that we will give to the enemy in order to think for itself. Let's look at our example for the enemy. We would like our enemy to be able to patrol, chase if it sees the player, and attack if it's close enough. In order to do that, we would need three states: patrol, chase, and attack, and also two decisions. So in the patrol state, if the enemy sees the player, it will transition to the chase state, otherwise it will remain in the patrol state. And for the chase, if the enemy has the player in close range, it will transition to the attack state, otherwise it will remain in the chase state. Now let's see how we would implement this. First, we will create a script. Let's call it base state machine and attach it to the enemy. Now let's create the base state script. In the base state, we need three functions: execute, on exit state, and on enter state. The execute function will perform all the actions related to this state. The on enter state will perform all the actions that we need before entering the state. And for the exit state, we will perform all the actions that we need after exiting the state. Now let's create the base section. The base section is gonna be a scriptable object, and it will have a single function, the execute function, that will execute a specific action. In order to transition from one state to another, let's create a class called decision, and this class will have just one method called decide. This method will return either true or false based on the decision we provide. This decision class and also the base action are abstract classes, which means we do not implement anything here, we just write the signature of the function. Now let's create the remaining state class. This class will be used when, instead of transitioning to another state, we would like to remain in the same state. It will implement the base state and will have an empty body. I think we forgot to make the base state a scriptable object. So let's fix that. The next thing we need is the transition class. This one is responsible for switching between states based on the decision. First, we need three attributes: the decision and two states. Let's call them state 1 and state 2. The execute function will check if the decision returns true and if state 1 is not the remaining state, which means we are gonna transition to the state 1 if we do not want to remain in the same state. And then we do the same for the state 2. If the decision returns false and state 2 is not the remaining state, then we will transition to state 2. For now we don't have the transition to state method, but we will implement it next in the base state machine class. The base state machine is basically the brain of this whole system. For this one we need an initial state and a dictionary where we would store all the cached components. We will talk about it a bit later. We also need the current state. In the awake function, we would initialize the current state with the initial state and create a new dictionary for the cached components. In the update method, we call the execute function of the current state, which basically calls all the actions related to that specific state. Now the transition to state function, which changes the current state to the new state, but not before calling the onExist state on the current state, which will perform all the actions that we set when exiting the state, and then perform all the actions when we enter the new state. In Unity, we have a method called getComponent, which returns a specific component from a specific game object if this one exists. And this method is pretty expensive. So if you would need to call it, let's say in the update function, then it would decrease our performance. So in order to fix it, we override the function and make it so that the getComponent function will check if we have already stored the component in the cached components array, and if not, then we will perform the base getComponent function of Unity. And if we find it, then add it to the list. So we get it from the list instead of calling the getComponent from Unity every time. Now the last thing we need in order to finish creating the state machine is create the state scriptable object. This one will have a list of actions that will be performed when entering the state, a list of actions that are going to be performed when exiting the state, a list of actions that are going to be performed when executing the actual state, and the list of transitions. In the execute function, we loop over all the actions that are going to be performed in the actual state and execute them one by one. And we do the same for the transitions. Now for the onEnter state, we loop over each action in the onEnter action list and execute them one by one. And we do the same thing for the exit state. We loop over all the actions in the onExist state and execute them one by one. Don't forget to add the create asset menu at the top in order to create the scriptable objects. Now that we are done with the base system, let's create the actual states, actions and decisions we want for our enemy. Now let's create the patrol, chase and attack states by creating a state scriptable object for each one of them. And let's not forget to create also the remaining state scriptable object. For the patrol state, we need the patrol action. And this patrol action will tell our navmesh agent where we want the enemy to move. But before doing that, we need some sort of path for the enemy to follow. We have this patrol points class that takes the area patrol points game object and populates the patrol points array with its children. So that instead of adding all the patrol points manually into the script, we just put the parent and have all the path figured out. Also in the patrol points class, I've created this function to draw lines between the points so we can see them better in the scene view. Now let's set the initial state of the base state machine with the patrol state. In order for the state to work, we need some actions. So let's create a folder. Let's call it actions. Let's also create the decisions folder. We will need it a bit later. Now let's create the patrol action. The patrol action implements the base action, which means this is also a scriptable object, so we need the create asset menu. Each action will have to implement the execute method found in the base action and override it. This function will be called on update, which means it will be called each frame. For the patrol action, in order to move the enemy to a certain position, we need to use the navmesh agent. And in order to get the navmesh agent component, we use the method getComponent, but not the one provided by Unity. We use the one we've created in the base state machine. Even if we call this method each frame, it will get the component only once, so we don't lose any performance. The next thing we need for our patrol action is the point where the enemy needs to go next. And in order to figure that out, we need a path. And to get the path, we need our patrol points component. Now let's set the destination to the next point on the path. Let's add this action to our state. Let's first create the action using the scriptable object. Let's call it patrol action. And now we should add it to the actions list of the patrol state. Okay, we made a small mistake. In the state, it should have been a list of base action instead of list of base state. Now let's see. Okay, it's the only action here. Now it should work. Yeah, the enemy is moving, but not as we expect. So we need to change a little bit our action. So we should set the destination to the next point only if the enemy reached its previous destination. In order to do that, we need a function to check if the agent has reached the destination. We can check now if the agent has reached the destination of the current point, and if so, then we set the destination to the next point, otherwise we set it to the current point. Now it works as expected. Since the patrolling works, our next step is to create a script that checks if the player is in vision range of the enemy in order to transition to the chase state. The script needs a reference to the player, a float that represents the chase range, and let's also throw in the float representing the attack range. We'll use it later, so let's create it now as well. The next thing we need are the two functions that return true or false, depending if the distance between the enemy and the player is less or equal than the chase range or the attack range for the second one. In order to see the ranges in the editor, let's create some gizmos. Drop the script on the enemy. Drop the player into the player slot, and we can increase the chase range as we like. Let's set it to 5, and the attack range, let's set it to 2. Now let's create a singleton for the player in order to refresh it way easier in Scriptable Objects. We can create now the chase action. This one will be pretty simple. In the execute function, we will set the destination of the nav mesh agent to the player's position, and we will use the player reference we have previously created. We are ready now to create our first decision. This one will decide if the player is in chase range. In the decide method, we will get the component check player in range and call the is player in chase range and return its result. Now we can create the scriptable object for the chase action. We will call it chase action. And we can also create the scriptable object for our decision. Let's call it in chase distance decision. Going back to the patrol state, you can see that we need a transition in order to go to the chase state. So let's create one. Let's call it transition to chase. This one needs a decision, so let's put our decision. And if the decision is true, then it will transition to the first state, which will be the chase state. And if not, we would like to remain in the same state. So let's choose remain in state. Now let's go back to the patrol state and add our transition. Now we need to also add the chase action to the chase state. Now that we can transition to the chase state from the patrol state, if the player leaves our chase range, then the enemy should go back to the patrol state. So let's create a transition for that. And we'll call it transition to patrol. This one will take the same decision we used before, but now the first state will be remain in state. So if the player is still in chase range, it will remain in the chase state, otherwise it will transition to the patrol state. Let's also add our new transition to the chase state. It's time to test it. Let's see. So when the player enters the blue range, the enemy will begin to chase, and if the player leaves the blue range, the enemy will just resume its patrol. Now that chasing the player works, let's move on to attacking. I've given the enemy a weapon, and I've also attached an animator to it with a short attack animation. I have the animator set up the following way. We have an attack trigger and the transition from any state to the attack animation, and as the condition we have the attack trigger. Also, let's uncheck the looping for the attack animation. On the attack state, we will play an animation, so let's create an action for it. Let's call it play animation action. Let's also create a decision that is gonna allow us to transition to the attack state, and we will call it in attacking distance decision. This one is going to be pretty similar with the in chase distance decision, so we'll copy the decide method and put it here. Also, we need to make the class implement the decision, and don't forget to import the check player in range script. And we need to change the is player in chase range to is player in attack range. We can now create the decision scriptable object for checking the attack range. Let's also not forget to add the code for the play animation action. In this one, for the execute method, we will get the animator and set the attack trigger in order to play the attack animation. Now let's add our play animation action to our attack state. And let's add it to the on enter actions, because we want the animation to be played only once. And now let's create a transition. Let's call it transition to attack. Let's choose our decision, and if the decision is true, we will switch to the attack state. Otherwise, we will choose the remaining state. And now in the chase state, we can add the new transition, the transition to attack, and let's put it as the first one. And also in the attack state, let's choose the transition to chase. Now we can test it. Okay, it doesn't really go as expected. The animation should have been played only once. So let's fix it. Instead of having the same transition to chase in the attack state, the same as the chase state, let's create another one. I'm gonna call it transition from attack, but you can come up with better names. For this one, we are gonna choose the in attacking distance decision, and if this one is true, we will remain in state, otherwise we will transition to the chase state. This way it should work. Now we need to change the transition in the attack state and choose the new one. Now it works as expected. The enemy attacks only once, and when leaving the chase range, it continues to patrol. There is one more thing I would like to add to the system. I want the enemy to move slower at first, and when entering the chase range, I want it to go faster. So it seems like the enemy is rushing at the player when it sees it. Now we need to create an action that allows us to change the speed of the enemy. So let's call it change movement speed action. Base action. This function will have a public float that will be the new speed, and in the execute function we would get the navmesh agent component and set the speed to the new speed. Now in the editor, let's create two new actions. Let's choose the change movement speed action. Let's make this one the set patrol speed action and set the new speed to 2. Then let's create the second one. This one we will call it set chase speed action, and we will set the speed to 5. And the enemy will have the base speed set to 2. Going to the patrol state, we can add the set patrol speed action to the on enter actions.
And in the chase state, we can add the set chase speed action also on the on interactions. As you can see, now the enemy moves pretty slow. Let's see when we get in range. Yep, it works as expected. And if you leave the range, it should continue its patrol and also slow down. It may seem pretty complex and a lot of steps at first, but once you get the hang of it, it will pay off in the long term. And also, it will make the code more manageable and easier to debug, since the logic is split in multiple scripts. Now that you have the base of this system, you can create any type of AI you want. It may take a bit more time to get started, but it will save you much time later, when the project gets more complex. Thanks for sticking to the end, and I hope you found this tutorial useful. If you have any questions, make sure to leave them in the comment section. Thank you so much for watching, and until the next time, peace.